So we're continuing with our chi-square test, and let's see what we're going to do with this chi-square value that we found. So our Q, which is the sum of all the chi-square values in the box up here, that was 4.75. So what does that mean, and what do we do with this number? Well, we're going to compare it to a critical value. And as long as this Q number that we calculate is smaller than the critical value, if it's within the critical area, we accept our null hypothesis. If our Q is higher than the critical value, it means that there's more variation within our data set than we can explain by coincidence. So if this value is higher than the critical value, then we reject the null hypothesis and we accept the alternative hypothesis. So what do we compare it with? Well, in the exam, the value will be given to you. So you're given a critical value and you're asked to compare it to the one you found and draw your conclusions on the basis of that. For your math exploration, if you're doing your own investigations, then obviously you can't just be given a critical value, but you will need to use a table to find out what it is. So this table over here is a table of chi-square critical values. And the first thing we need to do is look at our data table. Well, not this one really, but the one with the original data, and look at the size of it. And I mean, this one has the same size as the original table anyway. So we look for first, we can look for the number of rows. And the number of rows is 2. And then we look for the number of columns. And the number of columns is 3. And now we're going to work out something called the number of degrees of freedom. So every table has a certain number of degrees of freedom, and we find the number of degrees of freedom by taking, so equal the number of rows, number of rows, so R for rows, minus 1, and we multiply that with the number of columns, minus 1. So in this case, that's going to be 2 minus 1 multiplied with 3 minus 1, which is, well, 2 minus 1, that's 1, and 3 minus 1, that's 2. So this table has 2 degrees of freedom. To put it simply, degrees of freedom means the more degrees of freedom you have, the more variation you will get between the data that you have. And you can see also in this table that the critical values will increase with a greater number of degrees of freedom. And now that we know the number of degrees of freedom, we can well, usually we decide on a level of significance, a significance level, before we begin our investigation. So in this case, we decided on a significance level of 5%. So we're going to be concerned with the column that reads 5%. And 5% is the same as 0.05. So in this case, it's this column that we're going to compare with. It means that the critical value that we're looking for is in that column. And then we could look at the rows down here where it says degrees of freedom, that we're interested in the row that has 2 degrees of freedom. So it's this row that is marked 2. And you can see the intersection point between the column and the row. That gives us a critical value of 5.991. And then we make a comparison of these numbers. So we have our Q value, our chi-square value of 4.75, and we can see that this is less than 5.991. And that leads to our conclusion. Our chi-square value does not exceed the critical value, so we accept our null hypothesis. And here's the reason why it's important to state our hypothesis, so we can backtrack and have a look at what was our null hypothesis, and that is that language choice is independent of gender. So whether you're a man or a woman does not have a significant influence on the choice of language, or we cannot say that they are linked in any way. We don't have sufficient evidence.